hi everyone. Today I'm going to speak upon one of the most coolest project in the CNCF, which is Cloud Native Buildpacks. And the agenda here would be to understand that how we can use Buildpacks as an alternative to Dockerfile, especially to make life easy for the developer. A bit about myself. I am working as a senior DevOps engineer with SAP Labs, Bangalore, India, and I'm a community member and speaker with Docker Bangalore, CNCF Bangalore group. And I do. I'm also a tech blogger. I do post articles on platform as a service, cloud native and microservice on different social platforms. Okay, so coming to the agenda. So here today we are going to quickly discuss about Dockerfile, what is the shortcomings of this current approach, and how Buildpacks basically solves it, and what is this Cloud Native Buildpacks is all about. A bit on the demo, we'll see a quick demo around it, and then why should we consider Cloud Native Buildpack over a traditional Dockerfile approach. Okay, so Dockerfile, as we know, is basically an instruction set which helps a developer to basically build a runnable image. So you basically mention a set of instructions within that file, and then you pass it to the Docker daemon, which finally creates a build image. And it's considered as a best friend for a developer to Dockerize any polyglot-based applications. And definitely Dockerfile has certain advantage regarding faster application development, speeding up the incremental builds, as well as easier management and scaling up the containers. If you look closely, a Dockerfile looks like something here, like where we mentioned that what would be the base operating system from where we are going to build the application, and then what are the dependencies that we are going to put it here. Along with that, we mentioned what configurations we are going to do for that particular applications, what would be the working directory, how we're going to start the application, and then finally how the port would be exposed. And the result is something like this, where we get each instructions which are nothing but a set of layered images which finally creates the Docker image. So it's basically a set of layered images, read-only images, where you get the full-fledged application image. But building a particular app in a Dockerized way using Dockerfile is the simplest thing. But then again, it has certain shortcomings. The application image built through a Dockerfile is often bloated with extraneous cache directory, and the real performance comes during the speed builds. Another thing is that we have seen is about the composability, like building the multiple Docker images required, where you have to specify if you're like using some of the dependencies a bit of the Docker image from the previous build. You have to mention it through a multi-stage build process. But again, if you're using that, then you cannot use the environment variables directly. You cannot follow a symlinks, and also file system layers has to be manually copied. So it has a leaky abstraction. So Dockerfile, I would say, is a very poor tool for application developers who want to actually write quality code. Basically, it's not application aware. So when the developer is basically building the application, he must be knowing about that what logic should be there within that Dockerfile, which actually builds that quality image. And so it raises concern about operation and application developer concern, because the developer would know how to build an application, but then when it goes to any ops person building the Dockerfile, then he may miss some of the configurations which was being done, which was actually needed in building that particular application. So another important factor here is about the maintenance, which is normally very tedious and time consuming in using Dockerfile. So when you are actually creating Dockerfile for multiple applications, often we go about copying the informations from one Dockerfile to another Dockerfile, and then basically changing some certain configurations. And this can basically introduce certain low-level concerns, and it basically impacts the final quality of the image which is produced. So then what is the alternative to Dockerfiles? Well, there is one which is called as Buildpacks. Buildpacks is something which is kind of a pluggable modular tools, and which translates your actual source code into an OSI native format image. It provides a very high level abstractions for building your applications compared to a Dockerfile. It uses particular the builder concept, which bundles all the bits and pieces of information against your source code and creating the final artifact, or we call this the droplet also. It was originally conceived by Heroku in 2011, and then this has been actually being used across multiple platforms in Cloud Foundry and other platforms as a service technologies such as GitLab, Knative, to basically widen it to modernize the current application development process. Primarily, the Buildpack basically comprises of 3 steps, which includes the bin/detect, bin/compile, and bin/release. Basically, here what happens is, first of all, the platform determines whether the actual application development environment is there or not, where we can apply the Buildpack. If it finds one, then it basically applies all the dependencies which is required to basically use along with that particular source code. And then finally, it releases your image, which is again a layered OSI image, and that is created into a final artifact. So coming to that same concept, what it got evolved is something called as a Cloud Native Buildpacks. It was basically a project which served as a vendor neutral body to unify the whole of the Buildpack ecosystem, because Buildpacks was initially being conceived by Heroku, though Cloud Foundry was following a different versioning of that particular Buildpack. So there needs to be certain body which can govern across these 2 versionings into a common platform. So with this purpose, Billpack got introduced through Pivotal and Heroku in Jan 2018, and then it was inducted as a Sandbox project in October 2018. So basically, Billpack takes your source code and basically creates a final Docker image without the pain of basically writing the entire instructions of building that particular applications. Coming into the component sides, Buildpacks has a component called as Buildpack. Builder. The builder is an image which bundles all the bits and pieces of information which is required to create the Buildpack, and basically it has the built-in image also. So it is executed against your application source code. So basically, it has something called as a TML file where you mention what are the Buildpacks which should be applied against your app code in an ordered manner. And along with that, it contains something called as a stack. Stack is basically comprises a base image and a run image. And then you finally create a builder image. So builder image comprises of all the ordered set of Buildpacks and a life cycle which governs that how the application artifact would be produced. So it goes through multiple stages, and then along with that build image. Next comes is that Buildpack. So Buildpack is actually where it inspects that actual source code. So basically it determines from the source code directory whether, let's say for example, if it's a Ruby application, then it will try to find a gem file. If it's there or not, if it's a Java application, it will try to find a pom.xml. And if it finds, then it basically creates a build plan which can be applied against that particular application. And so it basically has these 3 files for execution, which is the buildpack.qml, providing the metadata about this Buildpack to be run. Bin/detect is something which determines whether the Buildpack should be applied or not. And bin/build is basically executing the Buildpack logic. So coming into understanding how Buildpack actually does this kind of orchestration, we have to understand this life cycle process. It basically goes through 5 different processes. First is the detect phase. Detect phase is the area where basically the platform chooses whether the Buildpack should be applied against the application source code or not. If it has to be applied, then it creates a build plan around it. Second is the analysis. Analysis where the metadata about the OSI layers which were generated from the previous build are taken into account, which can be used in the current build execution process. The restore phase doesn't normally come in the first build run, because this is something which uses the cache layers from the previous build that happened, so that it can reuse the existing layers and basically speed up the process of creating that final image. The build is where the Buildpacks uses the available metadata to generate the actual OSI layers which needs to be replaced. Let's say if you have basically created some application with version 1, and then again we deploy another application with slight modification, maybe on the code side with version v2. So what the build process will do, it will keep in intact all the layers where there is no change that has happened, and only replace that layer which needs to be which requires certain change. So next comes about the export phase. Export is where the remote layers are replaced by the generated layer. So this is the place where your final artifact, or we can say that OSI layer, gets created. Then the come is the stack. So stack is something which forms the core of basically creating this whole Buildpack logic lifecycle. So it basically comprises something called as a build image and a run image. It provides this build image when that builder image is created, and when the source gets along with that particular build image and the final app image gets created. So the execution environment which was running with that build image gets replaced with the run image, which is again provided from the stack. So in turn, if we see, unlike in a Dockerfile where we have to mention every time whatever it's the base OS image from which on top of which we would be creating an application, here from the platform side we are already mentioning the build image and run image, which would go intact together to create the final artifact. So one of the most important property of using Buildpacks, or you can say one of the coolest feature here, is about this image rebasing. So image rebasing is something where if you need to replace your actual run image, where you're basically have deployed your application, and let's say, for example, I suppose there are certain CV vulnerability which is being detected, and you need to just replace your base image with the patch OS image. So how you do it? You do it using the rebase command. So rebase is something which basically take into account your existing OS image. It replaces that with the new patch image without rebuilding the whole application. That means your entire metadata layers remains unchanged, and you just get the new patch image version. So then how we go about building a cloud native application using Buildpack? So first of all, we have to select what is the builder that we are going to use. So again, builder depends what is the kind of application environment where we are going to use to create that application. And then basically we would use a pack build command to basically build that final image, and then we would basically run that image. So you can use that image as a Docker image, you can use it to run on a Docker environment, or you can basically use this image to work on and deploy on a Kubernetes environment. But for Kubernetes, we use a separate utility which we call as a Kpack that is mostly compatible with the Kubernetes based resources, which I'm not going to discuss today. But yeah, it definitely helps in that particular platform. Okay, so we have enough of talking. I'll just quickly run through a quick demo to help you all understand how we basically use with this Buildpack. So if we see, so I have a pack installed. I've just installed the latest version, which is 0.11.2. First of all, what we get to see here is the available stacks. So stacks is something, as I told you, comprises of both the build image and the run image. So here the stacks is currently being provided from the Heroku and from the Cloud Foundry. So we have 4 different types of stacks that is available, and so these are again being used in the builder notation. So to list what are the available builders which you get from the platform side, I'll just give this command called suggest builders, and here you get to see the list of builders which you can use it. So as I mentioned, based on the type of application that you are deploying, you can basically choose what is the builder that you can use in this case. Let's say, for example, I am going to deploy a Golang application. Then I can use this Packet Buildpack, which basically supports a Bionic, Ubuntu Bionic base image for deploying this Golang application. Again, if I just want to create a small-fledged build image, then I can just use the tiny builder just to deploy the application. Okay, so now you can further go a little bit deeper and inspect about the type of what are the type of dependencies that goes within this particular builder. So if you see here, so basically a builder basically comprises of, so it will basically list the pack CLI version. What is the stack? It's using the lifecycle versions, which it comprises, and this is the Buildpack API lifecycle. And then it basically comprises the run image that it would be using for finally creating the app artifact. And then also it will contains a list of Buildpacks. And here is the detection order, that how the Buildpacks would be detected against your application source code in this particular sequential manner. Okay, so I'll just quickly deploy one simple Golang application, which I have in my GitHub repository. So it's just simple Golang application. It's nothing fancy about it. And what I will do, I'll basically use the pack command. And before that, I need to choose which is the builder that I'm going to use it for. I'll just use the smallest builder builder in this case, just to save some of my time here. And then I'll use the pack build command, just give my name. Okay, one more important thing about this pack tool is that it helps you to publish this image directly in the registry. So unlike a Docker based approach where you basically create an image locally and then you do a push, it's just like you create an image and you push it to the registry, and it's quite a cool feature. So let's say I just name the application as just name with Cloud Native Go, and then I'll just give the builder option here, and then I have to just pass on this flag called as publish. So once I give this, it will just try to download the base image from that particular builder image that it is that has been specified there. And then again, it's a Docker based image, so it will be pulling it from the registry. So once it has pulled it, it will start the lifecycle phase. So as per the lifecycle phase, it will first go to the detection section where it will detect the Buildpacks based on the grouping which we have, which has been mentioned there. It will analyze then whether this particular image coexists in the registry or not. If it is not, so it will not do anything. Restore will not take place in the first case because it's the first run, so it has nothing to restore from the previous build steps. And then it will go about creating the OCI layer. So in this case, it will basically download all the dependencies from the internet, basically the runtime dependencies, whatever the based on the type of application we are deploying. Like say, for example, in this case, it will be downloading the dependencies, and then it will be installing everything. And finally, in the export phase, it will create the build image here. So now, if I see here, I can simply use Docker. Okay, so before that, I just want to show you one more thing. So once you have this application, so you can use it to inspect from the remote side also. That means I don't have this image in my local environment, but I can use the inspect image command. And then I can just give BOM is something called as bill of material, and then I can just mention the remote option here. So what it would do, it would basically fetch what are the dependencies that has gone inside this particular images. If someone wants to see that what are the versions that has gone into that, he can directly see it from that image that has been published now in the remote repository without being created locally on his own environment. So now I can just simply run a Docker command just to ensure that my image is running. And I'll just publish on port 8080 where it's running, and I'll just give my application name. And now it's pulling that image from the registry, and hopefully it should create the container. Yeah, it's created. Just to check the container is up and running. Okay, it's up and running. So I'll just use my port just to ensure it's up and running. Yeah, so you can see that the application is now running. Now the thing is, let's say for example, I need to again run this particular build command once again for this image. So what happens? So I can basically, if I just run this pack build command once more, it will try to basically go through the same life cycle phase, but in this case, because the run image is already there, it will not pull. What it will try to do, it will restore from the already run images, the dependencies, whatever it's there, it will try to pull it from there. It will not touch the existing metadata layer. It will just see whether there has been any change in this particular application code, which it needs to import inside the OSI stack. So if it doesn't find anything, it will simply run it and it will ensure that the artifact is created. So should be done in quickly. And then it starts exporting. And basically it's create the final app image for me. So it doesn't use anything in this case. So this is the way how we basically go about using Buildpacks. Then the next thing comes, then why we should consider using Buildpacks when Dockerfile in its place. So main thing comes because of this separation of concerns. So first is like in this case, what happens in a Dockerfile approach, the developer has to take care of the full responsibility in defining the whole application stack. In this Buildpack case, the developer just concentrates on the logic in defining the application source code, while the dependencies are being taken care from the platform itself. And the second thing that comes here is about ensuring that the application are patched with the correct OS images. If some vulnerabilities are already introduced in the existing OS image, in a Dockerfile based approach, you have to basically redo the building of the complete Dockerfile, right? You have to replace it. You have to basically then define the set of coding there, like the set of instructions that will go, and you have to rebuild. But in this case, you just point the reference from the existing metadata layer to the new updated one. And both of these images are ABI compatible, which are being guaranteed from the platform side itself. So here is the Dockerfile approach. As I told you, the developer rebuilds all the affected containers for the application which is running in the environment. For the Buildpack approach, it's just the developer is just building his own application logic, while in parallel the platform team is taking care of rebuilding the base layer with the correct patch OS version. So on the advantage side, yes, it meets the security and compliance requirement without much developer intervention. We don't basically disturb the developer as such. He just concentrates building his own code behind creating that application. So it provides an automated delivery for both your OS level and application level dependency upgrades. It can efficiently handle the data operation or maintenance, which is difficult to use with the Dockerfile. And it can basically variably use ABI compatibility to ensure that both the base layer, the runnable image where your application is building, are compatible on the platform side. It rebuilds and uploads the layers when necessary. Not only it will do every time, only if there is any change it will do it. And then it supports the cross repository block mountain across the Docker registry v2. So this was all with the Buildpacks. So I will be happy to take any questions, or if I have some time for that.